All right, hello once again. This is Jeff Scott of Rankin Technical College. Last week, I lectured on Chapter 14 for the C Sharp of our C Sharp book, Microsoft Visual C Sharp, An Introduction to Object-Oriented Programming by Joyce Farrell. I had some technical problems with the recording. This happens every once in a while. So I'm re-recording both the Chapter 14 lecture and the test review. Even though students have already taken the test, I like to just do this for completeness. So I'm on page 655, and in this chapter, we learn about computer files, the file class, the directory class, file data organization, what streams are, how to both write to a sequential access file and how to read from a sequential access file, how to search a sequential access file, and finally we'll end up talking about serialization and deserialization. So, in the earlier chapters in the book, everything we've done, and it's funny when the author says in the earlier chapters of the book, in the first 13 of 14 chapters in the book, every time we ran a program, once the program executed and we got results, when the program was over, the results were gone. In other words, the results of our program did not persist. If you want the results of your program to persist, you must do one of two things. Either you must save the information to a file, or you must save the information to some kind of a database. In this chapter, we're going to go over files and how that's done. Now, we are going to talk about databases, and I'm going to have some lectures on databases also. That said, with the database stuff, there is basically nothing in this textbook about database. So I'm going to be going to outside or auxiliary type of materials to go over the database portion. All right? So, when data items are stored in a computer system, they can be stored in various ways. Temporarily using what's called RAM, or main computer memory, random access memory. Random access memory is subject to electronic power. In other words, it is volatile. So in other words, when the program ends or when the computer loses power, whatever you had saved is gone away. On the other hand, if you save something onto a flash drive or a CD or a DVD or even the hard drive of a computer, that's non-volatile storage, because once you've written it to the program, it's there permanently unless you do decide to manually go and get rid of it later. So the author says in this little paperclip here, temporary and permanent refer to volatility, not length of time. Now, a computer file is a collection of data stored on a non-volatile device. Text files, these types of files right here, also known as data files, are the kind of files that you can read in a regular text editor. All right? Binary files are files that have not been encoded in ASCII, Unicode, whatever, some kind of character set. So you can't read them using a regular text editor. I've given this example before. So if I were to go in here, here's an article that I was looking at the other day from the Simple Programmer, all right, and I'm looking at it in Word. Not a problem, right? But if I go and try to bring up that same article, let's see, where am I here? Okay. If I try to bring up that same article and I try to bring that up in, let's say, Notepad++, for example, it looks like this. Let's put it this way, it's going to be ugly. Because I'm trying to read a non-text file or a binary file using a text editor. All right, doesn't work. So image files, music files, video files, executable program files. Those are examples of binary files. Like text files, binary files have names. They have a create date, a last modified date. They're put on a device. They're measured in bytes. A byte is basically the equivalent of a character. They mention here we're talking about kilobytes, which are thousands of bytes, megabytes, which are millions of bytes, gigabytes, which are billions of bytes, and even what? We've got terabytes, which are trillions of bytes, and then I don't know what's next, petabytes or something like that, which are like quadrillions or something like that of bytes. Important topics here. When you copy data from a file on a persistent storage device into RAM, so you're working with a copy, then you're reading from the file. If you take and you store something that has been in RAM and you store it to a persistent data device, you're writing to the file. As it says, some programmers prefer the term persistent storage to permanent storage. All right. At the top of a file system is what's called the root directory. So it's kind of like if you throw everything and you don't create folders, etc. for it, you just start throwing stuff in, it'll be saved in the root directory. Most people, rather than doing that, they organize their files into what are called either folders or directories. Now, whether you use the word folder or you use the word directory, in part, will depend on how long you've been doing this. All right, and I've been doing this for 30, 40 years, whatever it's been, and at the beginning, everybody called them directories. But that's before we were graphical. Today, you see these things like we've got right here, and those are referred to right there as folders. But I can still go in here. If you notice, I've got 3 folders. But if I come through here, and I type in here CMD, and I say CD, so here, that's where I just was. And I say MKDIR Jeff. All right. Now, you'll notice that once I do this, there it is. I just made it. So I made a directory, but it is shown basically as a folder. All right, I think it's enough of that. When you talk about a path to something, here's an example of a path. I'm on the C drive. Under the C drive, I've got a C# folder. Under the C# folder, I've got a Chapter14 folder. Under the Chapter.14 folder, I've got a file named data.txt. Again, as they mentioned, many people use directory and folder synonymously with one another. All right. C# has several classes that allow you to work with files, etc. Most of the time, if not all of the time, when you work with these, you are going to have to be adding the following statement to your programs. Where you've got your using up near the top of the program, we all know what that is. You'll be saying using system.io. All right, again, basically what that's saying is I want to be able to use the built-in C# input-output stuff. So when we work with files, files have a create date, etc. But here we can create a file, create a text file, delete a file, see whether or not a file exists, get the date when the file was created, that was last accessed, last written to. We can move a file, etc. That file class is contained in the system.io namespace. That's why we had to say the using system.io that I just showed you. Here on page 659 is a simple example of a program that first tells you to enter a file name, then it checks it if the file exists. It tells you that it exists. It tells you when it was created, last accessed, and last written to. People get confused over these terms. Last accessed means the last time you brought it up, not necessarily that you wrote to it at that time. And if the file doesn't exist, you just give them a message. So here are 2 program runs. First, you put in myletter.txt, and it comes back file does not exist, because evidently it does not. Here we've got businessletter.txt, and it says it does exist, when it was created, when it was last accessed, and when it was last written to. Now you have similar things that are available to you in the directory class. All right. So as it says, the create directory creates a directory, delete deletes a directory, exists will show you whether or not a directory exists. And as we looked at before, you can get creation time, last access, last write time, there's a move type of command, etc. And they run another similar program. But what this one does, so notice if we look on the next page here, we've got a for loop. What this does is it says if we put in a directory name that doesn't exist, like customer info, we just get a message back. But if we put in the name of a folder or directory that does exist, like client memos, it shows us all the files that are underneath it. As always, the author has online several of her programs regarding file handling. I should say a video regarding file handling. Businesses typically store data in some kind of a hierarchy. Now, I'm going to go a little further than what they talk about in the book, but you've got what on the bottom level? You've got a character. All right? And that's basically any keyboard character. All right? When you take one or more related characters and you put them together, you get a field. Why one or more? You could have a field like middle initial. That's just one character. You could have a field like email address, which could be scores of characters. All right. Then next you've got a record. What's a record? One or more related fields. And then next you've got a file. And what's a file? One or more related records. Now we're talking about files in here, but as far as I'm concerned, that definition we just gave for a file is the same one that you could use for a database. So a file is made up of records, which are made up of fields, which are made up of characters. A database is made up of records, which are made up of fields, which are made up of characters. And there they show it pictorially in figure 14.5 on page 662, but it's pretty much what I just went over with you. All right, so there we just looked at a character. There's a field, there's a record. You can have two different kinds of files. You can have a sequential file where each record is read in order from the first to the last in the file. And you can have a random access file where the records can be accessed in any order. Now, some of you watching this may be too young to even know what I'm talking about, but it's kind of the difference between a cassette tape. Back in the day when I was in, I don't know, high school or whatever, I had cassette tapes. And if I wanted to listen to song number 7 on the cassette tape, and I was at the beginning of the tape, I'd have two things I could do. I could either listen to the first 6 songs, or I'd have to fast forward through the first 6 songs. It wasn't like once we got things like CDs where we could press a number and boom, just jump to that song. So using a cassette player is like sequential access. Using a CD player is like random access. All right. When you open a file in a C# application, you create an object and associate a stream of bytes with that object. When you no longer need the file, you close it, so it's no longer available to your application. Typically, if you don't close the file, all right, nothing bad will happen. But if you've got a huge data file, and let's say that you've got some inclement weather, and you get hit with a lightning strike, it's possible if the file is still open that it could become corrupted. All right. They show a picture here in figure 14.6, and in that picture, I'm going to try to, there we go. It says when you perform an input operation, information is flowing through the system, the application modifies or possibly does something with that data, and then it flows out of the system. And they equate this to a stream, which is like a pipeline or a channel. In fact, I used to show a picture similar to this when I would teach introductory computer information systems, data processing, IS or IT, whatever you want to call them, classes, where this was data being input into a system. The system would manipulate that data, and what would be output from that would be information. So really, that is what a computer system does, is it converts data into information. There are three streams that are associated with your programs. One is console.in, which is the standard input stream, which by default is the keyboard. Now, if you're using a mobile device, so if you're using, for example, a tablet, you might not even have a keyboard. So it might be a touch screen. There's console.out, which is by default the screen, but you can redirect that to a printer, for example. And console.error, which again writes things to the screen, and again can be redirected to something like a file. We've been using the console.out's write line and write methods throughout. We've been also using the console.in's read line and read methods throughout this course. Now, when you read from or write to a file, as it says, you use a file processing class. You use stream reader for text input, you use stream writer for text output, and you use file stream for either inputting from or outputting to a file. It's a little quirky in what you do because it's different. When you write a program that stores data in a file, as it says, you create a file stream object that defines the file's characteristics and abilities. In other words, it exposes a stream around a file. These are different things that you can check on it. Can you read from the file? Can you write to the file? Can you jump to a certain spot in the file? How big is the file? What's the name of the file? Where are we currently located in the file? So you'll do things like this. So what we're doing is we're saying out file is the way in our program we're going to refer to the file called sumtext.txt. We're opening that file with create permissions, which says that either it's a new file and we're going to create it, or it's an existing file and we're going to overwrite it. And we want to be able to write to the file, so we're opening it up with write access. Some of the available modes that you can use in here are shown right here. There's a big difference between file create and file append. With file create, it creates the new file, but if it already exists, it's overwritten. With append, it takes what's called the file position pointer, and it positions it at the end of the file so you can add new data to an existing file. Notice there's create and create new. Create, if there is already a file by that name, it automatically overwrites it. With create new, it creates a new file, but it checks first that if that file already exists, rather than creating a new one, it throws an I/O exception or an input-output exception. Open opens an existing file. Open or create opens an existing file, but if it doesn't create it, if it doesn't exist, it creates it. And truncate removes all the information from a file, so it still exists, but its size is 0 bytes. When you open up a file, you open it up typically in one of these three modes: read, which is read only; write, which is write only; and read-write, which allows you to both read from and write to the file. So they've got a program here that goes and starts to run through that. So we create this file stream object, and then we associate it with a stream writer. All right. This could also be, if we were doing it here, we could associate it with, instead of a writer, we could associate it with a reader. But then instead of create, we'd have open, and instead of write, we'd have read. And in here, we'd be using read line, and probably call this reader, and we'd be using like read line, or reader.readline, something like that. Reading and writing a sequential file, page 668. The author says, although people think of data files as containing fields, C# uses files as only streams of bytes. In fact, some books will equate this to kind of like a hose, that a fire person could have, where they turn on the hose and water just starts streaming out. In the same way, That's how information comes out of a file. All right, so writing data to a sequential access file. We could do it like this, which is kind of the way we've been doing it, but it says, that that's not going to persist. So if we want it to persist, as it says, we'll do something like this. So we'll create a file stream object called outFile, which we will, we can either give this another, a name up above. You don't use literally the name file name, or you put a name in there. If it's going to be for reading, if it's for writing, we'll do a create and a write. When we do this, we have to find some way to what's called tokenize what we're doing. In just the same way that this book is made up of chapters, which are made up of pages, which are made up of paragraphs, which are made up of sentences, which are made up of words, which are made up of letters. Each word that you see in here, by and large, is separated by a blank space. That's the delimiter that we'd be using. All right. They talk about a priming read in here. That's this. Notice we've got a while statement. But everything we're doing in here before that, the stuff that you see before the while, so the stuff up in here, this is our priming read. That's our attempt to read the first record. If it exists, we process it and then read the next one. If it doesn't exist, we just skip it and close our objects. Talk about a magic number here. This is a magic number. All right, it says enter an employee number or 999 to quit. So if you've got a hard-coded number in there that you're using without any explanation, that's what it means. Sometimes you'll see, rather than something like this, it'll say enter employee number or stop, S-T-O-P to quit, where stop is used instead of 999 because it makes a little bit more sense. All right. In much the same way that you can write, to a sequential access file, you can read from it. Again, then you want to open it with read mode and associate a stream reader object with it, and then you'll be using read or readline. And they give an example here where they use the same employee, file they were working with before, and now they're going to read from it. All right, the key thing is that rather than writing to the screen, which is your standard output device, or rather than reading from the keyboard, writing to the screen or reading, what you're doing is you're redirecting those. So I'm either writing to a file or I'm reading from a file or both. Now they talk about the split method, and I probably quickly ran through that, but when you're tokenizing, so when you're breaking this thing down, and let's say that I wanted to create a file where I did something like this. I wanted, let's say, my last name, a blank space here, how many hours I worked, how much money I make per hour, and my gross pay. All right. The comma with a blank space, that's my delimiter. All right, and this is actually typically referred to as a CSV, or a comma-separated variable file. The split method, if I use that, in the split method, I have to let the system know what my delimiter is, so it knows how to split whatever my input is into different tokens based on that delimiter. Okay, I have the students go through this example here. We went through it as a class on 674, 675, 676. The idea is we read 10 names into a file, and then we end up writing them back out. All right. Well, you might not only want to read from a file and write to a file, you also may want to be able to search through a sequential file. So I might want to find all of the records that meet a certain criteria. When I do that, I'm using the file's position pointer. And the example that I gave in class is, look at it this way. It's like in the, quote, olden days, unquote, when you used, you had an LP, an album, and you had a phonograph, and you picked up, you used your hand if you're to place the phonograph needle on the song you wanted to hear. That phonograph's needle was kind of like the file's position pointer. And here we're telling it to go right to the beginning of the file. Some of the different things that you can use with it: you can jump to the beginning of the file, you can jump to the end of the file, or you can specify where you currently are in the file. So in this programmatic example here that's on 678 and 679, you can come in here and run a program where you ask if something meets a certain criteria. There were 3 records in here. In fact, let's just look at them. They're right there. These are the 3 records. Davis, who made 42 grand, Lorenzo, 52 grand, and Santini, who made 60 grand. Here we're saying, would you please show us everyone who made greater than $50,000? So you can see Davis is not shown. Everybody who made greater than $55,000. So Davis and Lorenzo are not shown. Anybody who made more than 0, so all 3 are shown. All right, so this particular program example allows you to go through here and check for things that meet a certain criteria. It's somewhat similar when we get into the database stuff about talking about what's called a where statement. Then there was another UDoIt program which allowed you to go through that list of names that we put in, and it said, okay, I've got this list of names here, and with that list of names, there's the 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, and 10th name. Notice if I said start with 7, 2, 3, 4, 5, 6, 7, I get Gina, Hannah, Inez, and Juan. If I say to start with number 9, I just get Inez and Juan. Okay. All right. Going through this kind of quickly, but the last major topic that's discussed in this chapter is serialization and deserialization. Now it says here, writing to a text file has 2 disadvantages. Data in a text file is easily recognizable in an editor like Notepad, but it's not secure. And second, when a data file contains many fields, so if you've got a record that's got 15 fields in it, doing all this stuff can get very cumbersome. It'd be better to be able to write all 15 fields at once as opposed to having to do 15 writes. If you want to do that, you can do what's called serialize. When you serialize, you convert an object into a stream of bytes. On the other end, you deserialize, where you convert those streams of bytes back into objects. If you need an analogy here, if you've ever done any work with computer hardware, and you probably have heard about this, if you try to send information over the internet, that typically if you've got a humongous file, you can't send it all at one time. Rather, you chunk it up, or you put it into chunks. You send those chunks over a chunk at a time. All right, that's serialization. Then on the other end, you've got to take those chunks and make one big thing out of them. That's deserialization. To use this, you have to put serializable, the serializable attribute at the top of your program. As it says, in a class marked with the serializable attribute, every instance variable must also be serializable. The big thing is all things in C# basically are serializable. When you use this, you'll typically also put a using system.runtime.serialization.formatters.binary if you're working with binary files, and using system.runtime.serialization if you're working with text files. All right, they give an example right here. Not going to run through that with you, but it will allow you to put your information in and serialize it or write it in one chunk. And then they show you what's actually happening when you do that. So the last thing that's actually discussed in this chapter, this is several pages long, is a UDoIt exercise, which begins on page 688. What you do in the You Do It exercise is you first create a simple project called Enter Invoice Data that has a label, a label, a label, a label, a text box, a text box, a text box, and a record. So you put information into each of these and you click Enter Record. All of the previous programs in this chapter were console apps. This is the one GUI app that they give in the chapter to allow you to write to a file. So when you put all this stuff in and you enter, you put everything in here and you click Enter Record, it writes it to a file. Now I'm having the class put this in, but make a couple of changes to it. Right now the invoice number and the amount are just put in there, and they're not checked to verify that indeed they're numeric. I'm making the students do that. So all of the code is shown here. This is interesting because what this line right here shows, that's kind of gray but also blue right there, is that's giving a path. If you do not give a path to your file, all right, if you do not give the file a path, what happens is when you create a file, a text file within a program, it gets saved to the bin directory of your program. The bin directory is in the debug directory, and that's where your executable file will be. So it saves the text file in the same folder or directory as the executable file unless you give it a path. You need to using system.io. We talked about that before. All right. And then you create a second program that will work with the first one. The first one allowed you to input the data. This second one that begins on page 691 allows you to output the data on the screen. So it'll show the first record. When you click Enter Record, it'll show the second one. When you click it, it'll show the third one. If you only have 3 records, right now, until you make a change in the program, when you click Enter Record again, you get an error message because it's trying to read the 4th record and there are only 3. So you will get something, I think it shows it here, but we'll find out. You end up getting an error, an unhandled exception. So you go back to the same program and it tells you that if we want to do that, we put the whole thing into a try block and then we check for a null reference exception. So if we've got 3 records, once we read the 3rd one, if we attempt to read a 4th record, we change here where it says, where previously this said, click the button to view records, this changes to you have viewed all the records. We gray out or disable the button and just keep it on the last record. Now that's it for the chapter. So I'm going to see where we are for time here. We're only at 33 minutes. So what I'm going to do is quickly, if I can, I'm going to try to bring up the review that we did for the test. All right, so RAM or random access memory is stored in memory, it's volatile, and it's lost when the program ends. Permanent storage, like files or databases, remains after the program ends. In other words, it's persistent or non-volatile. RAM is not persistent or volatile. Question 2. The terms directory and folder are typically used in the same way. They're used interchangeably when you talk about file organization. Number 3, the file class is contained in the system.io file. A CSV file is a comma-separated variable file that's typically separated by semicolons or commas, but it can literally be separated by other things if you want to or need to do that. Non-text files like music files, image files, executable program files are stored in binary format, which cannot be read by a normal text editor. When you read from a file, you copy information from a file on a storage device into RAM. When you write a file, you take what is in RAM and you write it to a persistent storage device. The file class contains methods that allow you to access file information, where the directory class provides information about directories or files. A character, any letter, any number, any special character, a special symbol that comprises data. A record, a collection of fields, and I already showed you this previously. A character is any keyboard character. One or more related characters are a field. One or more related fields are a record. One or more related records are a file, for what we're talking about now. Sequential access, you can't do what's called update in place. Again, it's more like a cassette player where you have to have an order to the items. With random, you can update in place. Again, it's more like a CD player. You can jump right to the record you want to change. When a C# app wants to open a file, it creates an object, and it associates a stream of bytes with it. We saw file writers, stream writers, etc. File readers, stream readers. When you close a file, it is no longer available to the application. A stream are how bytes flow into a program from an input device through a stream, which is a pipeline or channel. Typically, the program will manipulate that, and then it will flow out as well as output. A magic number, it's a bad programming practice that people still use that says, for example, rather than typing in the word stop to end, you pick some arbitrary value like -999. Split we looked at very shortly, very little bit. Split is a member of the string class, and I think I've shown you this before, but I'd like to again anyway, and that is if I go out here and I go to msdn.com, that's the Microsoft Developer Network. It pushes me off someplace else. There we go. And once I go over here, I can click the search button, and if I want to know more about Split, C#, oops, don't know what happened there, but something did. All right, let's do this. I'll type in here C# split method, and it's going to give me something in MSDN. There we go. So if you want to find out more, you can always go out to MSDN, the Microsoft Developer Network, msdn.microsoft.com, and do a search. All right. The file position pointer holds the current byte number, really the byte number of the next byte to be read. Serialization we talked about. However you remember this, serialization object to stream. Serialization, S-O-S. All right. Deserialization, D-S-O. RAM is also known as volatile or non-persistent storage. Remember, RAM is temporary. Some books even call RAM a computer scratch pad. Data files contain facts and figures. For example, a payroll file with payroll information in it. The root directory is the top directory in a system. So if you take it and start storing files and you just throw them someplace without creating folders or directories for them, you're going to be putting them into the root directory. A data hierarchy is how businesses store data. What do you mean by a hierarchy? Characters, which make up fields, which make up records, which make up files. All right, it's all stuff we've looked at. A character set, ASCII is an example, but it's an older one. Unicode character set, the set of all characters used to represent data on a particular computer. And again, most of the character set information or talk you have today is on Unicode. All right. A binary file stores music, images, executable programs, etc., stuff that cannot be read with a normal text editor. Permanent storage is subject to electronic power, not subject to electronic power rather, so it's not lost when the computer loses power. So if you turn the computer off, you turn it back on again and you save something to a file, the file's still there. A token is a block of text within a string that represents typically a field. A delimiter is a character like a comma or a semicolon that is typically going to be used, all right, to separate different field values. A field is one or more related characters with meaning. A path is a disk drive plus a hierarchy of directories plus at the end the name of your file. Random access file is a file in which the records are not in sequence as opposed to a sequential access file where they are in sequence. Finally, a key field is a field used to uniquely identify each record in a sequential file. So what I have done is I've gone back and retaped, and in one lecture, in about 40 minutes, I've given you both the Chapter 14 lecture and the Chapter 14 test review.